Good morning everyone, I'm King Mushinaratuk and I'm going to report about design of alignment and road facilities. So first, design of alignment. The alignment of a highway is composed of vertical and horizontal elements. The vertical alignment includes straight, tangent, highway grades and the parabolic curves that connect these grades. The horizontal alignment includes the straight tangent sections of the roadway and the circular curves that connect their change in direction. The design of the alignment depends primarily on the design speed selected for the highway. The least costly alignment is one that takes the form of the natural topography. It is not always possible to select the lowest cost alternative because the designer must adhere to certain standards that may not exist in the natural topography. So first is vertical alignment. The vertical alignment of a highway consists of straight sections known as grades or tangents connected by vertical curves. The design of the vertical alignment therefore involves the selection of suitable grades for the tangent sections and the appropriate length of vertical curves. Vertical curves are used to provide a gradual change from one tangent grade to another so that vehicles may run smoothly as they traverse the highway. These curves are usually parabolic in shape. Example, a crest vertical curve is to be designed to join a 3% grade with a negative 2% grade at a section of a two-lane highway. Determine the minimum length of the curve if the design speed of the highway is 60 miles per hour and a perception reaction time of 2.5 seconds. The deceleration rate for braking is 11.2 feet per second. So to determine the minimum length, we have to use SSD equation equals to 1.47 UT plus U squared divide 30 times A over 32.2 minus G. So distribute the given to SSD equation, we get the 598.1 feet. Then next, use the minimum length of vertical curve, and as you can see the A equals G2 minus G1, and our G2 is negative 2% grade minus 3% grade. Then we will have 5. Then distribute again the side of distance, 5 times 598.1 squared over 2158, and we get 828.8 feet, and that's our minimum length. Then next is horizontal alignment. The horizontal alignment consists of straight sections of the road known as tangents connected by curves. The curves are usually segments of circles which have radii that will provide for a smooth flow of traffic. The design of the horizontal alignment entails the determination of the minimum radius, determination of the length of the curve, and the computation of the horizontal offsets from the tangents to the curves to facilitate locating the curve in the field. In some cases, to avoid a sudden change from a tangent with infinite radius to curve of finite radius, a curve with radii varying from infinite to the radius of the circular curve is placed between the circular curve and the tangent. Example, the intersection angle of a 4-degree curve is 55 degree 25 minute, and the PC is located at station 238, 44.75. Determine the length of the curve, the station of the PT, the deflection angles, and the chord length for setting out the curve at all station from the PC. Solution. First is getting the radius of curve 5729.6 over D then distribute the given, we will have 1432.4 feet. Then next is length of curve. Radius of curve 1432.4 times the intersection angle of a 4-degree curve is 55.4167 times pi over 180. We will have 1385.42 feet. The station at PT is equal to station 238 plus 44.75 plus 13 plus 85.4 equals to 252 plus 30.17 stations. The distance between the PC and the first station is 239 minus close parenthesis 238 plus 44.75 equals to 55.25 feet. Then next is get the D over intersection angle of a 4-degree curve equals to intersection angle over length of curve. Then distribute the given, therefore we will have 2.210 degree. Then to our C1 equals to 2 times radius of curve 1432.4 sin times 2.210 over 2, we will get 55.25 feet. The first deflection angle to station 239 is equal to 1.105 degree equals to 1 degree 6 minutes and 18 seconds. Then the second intersection angle 252 plus 30.17 minus 252, we will get 30.17 feet. Then next, the second D over 2 equals to 30.17 over 1385.42 times 55.4167 over 2, we will get 0.6034 degree. Then next is C2. 2 times 1432.4 sin 0.6 times 0.6034 degree, we will get 30.17 feet. Then to our CD, 2 times 1432.42 sin times 4 over 2, we will get 99.98 feet. The next is road facilities. Special facilities for heavy vehicles on steep grades. Statistics indicate a continual increase in the annual number of vehicle miles of large trucks on the nation's highways. Chapters 3 and 9 describe large trucks as having different operating characteristics than those of passenger cars, a difference that increase with their weight and size. For example, as the grade of a highway section increase, the presence of trucks become more pronounced. Thus, it becomes necessary to consider the provision of special facilities on highways with steep grades where high volumes of heavy vehicles exist. The most common facilities that address this problem are climbing lanes and emergency slip ramps. A climbing lane eliminates the need for drivers of light vehicles to reduce their speed when they encounter a heavy, slow-moving vehicle. Because of the increasing rate of crashes directly associated with the reduction in speed of heavy vehicles on steep sections of two-lane highways and the significant reduction of the capacity of these sections when heavy vehicles are present, the provision of climbing lanes should be considered.